How's it going, YouTubers? Giovanni Orlando here, and today I will be teaching you about complex numbers. For more videos like this, you can visit my YouTube channel at youtube.com/GiovanniOrlandoI7. Let's get started. The first thing you need to do is understand the concept. A number can or may be considered complex if said number contains or is composed of a real part and an imaginary part. Complex numbers can be expressed in two forms: rectangular form, which some people know by Cartesian form, but I much rather use rectangular as a naming convention, and the polar form. In rectangular form, a complex number is expressed as follows: z equals a plus jb, where a is the real part and b is the imaginary part. In polar form, on the other hand, a complex number is expressed as follows: z equals r at an angle zeta, where r is the magnitude and zeta is the phase. Here you can observe a graph in which both the rectangular and polar form interact with one another. As you can observe, in what would be the x-axis, you can see the a value in the realm of the real numbers, and in what would be the y-axis, you can observe the b value in the realm of the imaginary numbers. As you can see, coming straight from the origin, we have the magnitude r, and it's in an angle zeta from with respect to the xy axis. A pretty common question is, how do I go from one to the other? In order to convert a complex number in rectangular form to its polar form, you must use the following conversion factors: a equals r times the cosine of our angle zeta, and b equals r times the sine of our angle zeta. In order to convert a complex number in polar form to its rectangular form, you must use the following formulas: r equals the square root of a squared plus b squared, and zeta equals the inverse tangent of b over a, where negative 180 degrees is less than zeta, which is less than 180, or negative pi is less than zeta, which is less than pi. Another common question is regarding the complex conjugate. What is a complex conjugate? Well, if you have a complex number z, which is equal to a plus jb, then its conjugate would be equal to a minus jb. Should you multiply a complex number times its conjugate, you would get a squared plus b squared, which is the magnitude or the r value squared. Now we discuss the Euler identities. The cosine of our angle zeta, or the phase, is equal to the complex number plus its conjugate, both divided by 2, and the sine of our angle zeta is equal to our complex number minus its conjugate, both of them divided by 2j. In this second graph, you can observe how the values vary depending on what quadrant they are. In the first quadrant, both the real and the imaginary part are positive. In the second quadrant, the real part is negative while the imaginary part is positive. On the third quadrant, both the real and imaginary part are negatives. And on the fourth quadrant, we have that the real part is positive while the imaginary part is negative. We are now going to go through some examples in order to put our knowledge on complex numbers to the test. The first problem we are going to be solving is on how to convert a complex number in its rectangular form to its polar form. Keeping in mind that a complex number in its polar form is expressed as z equals r at an angle zeta, where z is the complex number, r is the magnitude, and zeta is the angle or the phase. Let's say you have a number such as 1 plus j, which is equivalent to 1 plus 1j. The first thing you're going to want to start off by doing is finding the r value or the magnitude. R is equal to a squared plus b squared. For this case, our values would be 1 and 1 respectively. 1 to the second power is 1, meaning we end up with the square root of 1 plus 1. That results in the square root of 2, which is equal to 1.414. The second step would be to find the angle or the phase. The phase is equal to the inverse tangent of b over a. For this example, we have the inverse tangent of 1 over 1, which is equal to the inverse tangent of 1. And as we all know, or as you could probably verify using a calculator, the angle at which the tangent will give us a value of 1 is 45 degrees. Now that we have the r value and the phase, we can sum up our final answer. We said that r, or the magnitude, is equal to 1.414 and our phase is 45 degrees, meaning that z is equal to 1.414 at an angle of 45, which is equivalent to 1.414 times e to the j at 45 degrees. These are the two forms that you can express your final answer. The next example will be on how to convert from polar to rectangular. Now that you understand how to convert a complex number from rectangular form to polar form, I will teach you to reverse engineer it and convert a complex number from polar to rectangular form. Let's get started. It's important to keep in mind that a complex number in its rectangular form is expressed as z equals a plus jb. Let's say you have a complex number such as 5 times e to the 53.1301 degrees, which is equivalent to 5 at an angle of 53.1301. The first thing you're going to want to do is find the real part, which is the a value. A is equal to r, which is the magnitude, times the cosine of our angle zeta, which is the phase. In this particular exercise, our magnitude is 5, and our angle is 53.1301. Now, making use of a calculator, we will find the outputting value of this problem. We said it was 5 times the cosine of 53.1301. And that gives us a value of 3. Now that we have the real part, we will move on to finding the b value, which is the imaginary part. B is equal to r times the sine of our angle zeta, which means we have 5 times the sine of 53.1301 0.01. Once again, using the calculator, we will find our resulting value. And that gives us 3.9999, which is roughly 4. Meaning that our rectangular form would be z equals 3 plus 4j. That would be the final answer for our problem. Amazon links to both the Expo dry erase markers as well as the Casio FX 115 ES Plus calculator will be on the video description down below. If you enjoyed this video, please give it a thumbs up and subscribe to my channel for more videos like this, as it does help out a lot. And for any comments or questions, you may contact me on the following places: at Twitter at Giovanni0918 or at Google Plus at +Giovanni Orlando I7. Thank you for watching. Have a nice day.